Now, how do we know if there is a reduction and an oxidation taking place? The key there is your oxidation number. Your oxidation number is like an accounting variable. What do we account for? We account for the electrons that an atom can gain, lose, or share when it is chemically bonded to another atom of another element. Basically, when you have an atom that is now a part of a molecule. So, initially, you have a neutral atom. When it becomes part of a molecule, its net number of electrons can change. It's because when it becomes part of a molecule, it would share electrons or it would donate some electrons to another atom. So if we can keep track of these changes in the number of electrons in an atom, then we can see whether there is transfer of electron. And we can do that by tracking the oxidation number of a specific element, a specific atom in a molecule or ion. So here in this table, you will see some examples. Remember, your oxidation number is specific for an atom. So, for example, we have here NH4 plus. This is your ammonium ion. You will need to mention the oxidation number of the two elements found in this molecular formula. So you need to know the oxidation number of nitrogen and the oxidation number of hydrogen. So sometimes oxidation number is referred to as oxidation states. So they are the same. So just take a quick look at the possible oxidation states of our elements. Notice that each element has more than one possible oxidation number. And its oxidation number depends on the identity of the second element to which it is bonded. Notice nitrogen, it can have -3, 0, +3, +5, and so on. Again, depending on the identity of the second element to which it is bonded. The same goes for sulfur in this list of sulfur compounds, and also carbon. What about our metals? All of our metals only have positive oxidation states or oxidation numbers, but most of them have more than one oxidation numbers. So they are more diverse in terms of the number of oxidation states. But for our nonmetals, like what we saw in the previous table, they can have positive or negative oxidation numbers. Now, do you need to memorize all of this? There are a lot of compounds that are known. So do you need to memorize tables like this? No. There are rules that you can follow to determine the oxidation number of your elements. So here are the rules. We have 6 rules, very simple. And I think if you have a good foundation of general chemistry, then you won't find it hard to understand these rules. So number 1, free elements, meaning they are uncombined, have an oxidation number of 0. So when we say uncombined, we see that in the chemical formula, it's the only element there. There is no other element. So for example, H2 or dihydrogen molecule, we only see hydrogen. Therefore, the oxidation number of hydrogen in H2 is 0. Oxygen or O2, it's not combined with any other element. So the oxidation number of oxygen in O2 is 0. Since we have two atoms of oxygen here, it means that both of the oxygen atoms in the O2 molecule possess an oxidation number of 0. That's rule number 1. Rule number 2. In monoatomic ions, the oxidation number is equal to the charge on the ion. This is again very simple. So if you have a lithium ion, we know that it became positively charged because it loses one electron. So lithium in lithium ion has an oxidation number of positive 1. Iron. So if iron, from neutral, it became iron 3. So Fe3 plus. And this is possible if the iron atom loses 3 electrons. So the oxidation number of iron in iron 3 is positive 3. So again, if you see monoatomic ions, the oxidation number of the element in that monoatomic ion is equal to the charge. So for oxygen, it's negative because oxygen tends to form O2 minus. So for this one, the oxidation number of oxygen in this ion is negative 2. Let's go to rule number 3. The oxidation number of oxygen is usually negative 2. We have exceptions to this rule, and that is if it is a peroxide. So you are familiar with hydrogen peroxide. It's H2O2. If it is a peroxide, the oxidation number of oxygen is negative 1. So peroxide has this chemical formula. It's O2 2 minus. So notice you have two oxygens there because of the subscript 2. And the overall charge is negative 2. So it's like each of your oxygen atom in this ion contributes a charge of negative 1, right? So two oxygens in peroxide, the overall charge is negative 2. So it's like one oxygen has a charge of negative 1. The other oxygen also has a charge of negative 1. So we say that the oxidation number of oxygen in peroxide is negative 1. So notice we are looking at the oxidation number of individual atoms. That's rule number 3. Let's go to rule number 4. The oxidation number of hydrogen is positive 1, except when it is bonded to metals. If hydrogen is bonded to metals, its oxidation number is negative 1. So an example would be water. From rule number 3, we know that oxygen usually has an oxidation number of negative 2. Since this is not peroxide, oxygen in water will have an oxidation number of negative 2. Now notice the overall charge of the molecule is 0. It's neutral, right? So for this negative 2 to be cancelled out, giving a net oxidation number of 0, there must be a positive 2 charge, and it will come from nothing else but the hydrogen. However, you have two hydrogens in this molecule. So it's like one hydrogen is contributing positive 1 charge. That is why we say that the oxidation number of hydrogen in water is positive 1, and the oxidation number of oxygen in water is negative 2. Let's go to rule number 5. Group 1A metals have an oxidation number of positive 1, group 2A positive 2, and fluorine is always negative 1. Okay, your group 1A metals, an example is lithium. Lithium, if it is an ion, has a charge of positive 1 and it's found in group 1A. Sodium, if it is an ion, it will have a charge of positive 1 and is found in group 1A. So, if you see a compound like lithium hydroxide, so you see lithium there. It's not a free element because it is combined with other elements. So, by rule number 5, automatic, you know that the oxidation number of lithium here is positive 1. Actually, we can continue assigning oxidation numbers for this compound. Through rule number 3, we know that oxygen here has an oxidation number of negative 2. And by rule number 4, we know that hydrogen has an oxidation number of positive 1. Now let's go to rule number 6. The sum of the oxidation numbers of all the atoms in a molecule or ion is equal to the charge on the molecule or ion. So you've already seen this when I try to count the oxidation numbers of your atoms. Let's go back to lithium hydroxide. So we've assigned the oxidation numbers, right? Now, if we check, I have one lithium ion. I have one lithium which has a which has an oxidation number of positive 1. So 1 times 1, that's positive 1. I have one oxygen which has an oxidation number of negative 2. So 1 times negative 2, that's negative 2. And I have one hydrogen which has an oxidation number of positive 1. 1 times 1, that's also 1. And if you add everything, the net oxidation number is 0. And what is the charge of this molecule? 0. So when you assign oxidation numbers, so after assigning, you can check if the sum of all the oxidation numbers of all atoms in your molecule or ion would be equal to the charge of your molecule or ion. So that is one way of checking whether you have assigned correct oxidation numbers.